James Franck, and I was born in Hamburg, Germany in August of 1882. I'm 42 years old now, and I've been nominated for a Nobel Prize. I was nominated for this prize for my experiment done with Gustav Hertz. And we actually were able to prove that electrons sort of live in discrete energy levels. So to prove this, it was an accident, but what the experiment was we took a tube and we vacuum sealed it and filled it with a mercury gas. And then we had a piece of a metal filament on one end, and we had two grids that would separate and sort of divide into three sections. And the first grid had sort of a voltage that would excite an electron from that filament, and then that second grid had a stopping voltage. And we were actually able to measure sort of the current that would come out with a changing voltage. And, well, realistically, we weren't quite sure what we were trying to, figure out. At the time, we didn't actually know about Bohr's theory, and, well, to be frank, we had neither read his theory or even heard of his theory about the atom. And we were really attempting to measure the ionization energy of atoms by hitting a diluted monoatomic gas with accelerated electrons, controlled by that adjustable voltage that I was discussing about. At the time of around when we did this experiment in 1914, I was still teaching at University of Berlin in Germany, and that's where I did a lot of my research, and that's where this experiment really happened. Shortly after our discoveries in 1914, World War I broke out, and I was already an enlisted soldier, so I actually got shipped out pretty quickly in that December of 1914. I started off as a scientist who we tried to take chlorine gas, and when the wind was favorable, sort of throw it towards the enemy, but that didn't quite work out. And so I actually began working with other scientists to create just a poison gas, but specifically I worked with the defensive and creating different gas masks and trying to be able to protect our troops. And actually a lot of us scientists were we used ourselves as the test dummies in order to see if these gas masks works out. And that's actually where I got dysentery and had to go to a hospital. This experiment was done by Gustav Hertz and I. Gustav was also nominated for this Nobel Prize, and well, we were good friends, and we did a lot of work throughout the war, and I would still write papers when I was in the hospital from my dysentery. I didn't really have a very specific role. Being Hertz and I's project, it was just two people. We just kind of sort of did everything together, I definitely did a lot of the paper writing, though. Well, at first, we kind of ended up hurting the physics community. See, we did misinterpret our data. We thought we were trying to discover ionization and that kind of thing, but well, since it wasn't ionized energy of mercury that this current was showing up from, with later see Einstein's photoelectric effect equation. Once he came out with that, we really were able to piece together that the 4.9 is really an excitation level of those electrons, and it hadn't anything to do with the ionization of anything. And then Max Planck, he was really thankful for our experiment because he was able to get a better, a more precise, H constant, what he's kind kind of known for. But most importantly, I think it really did prove Bohr's theory, which we hadn't known of at the time, that electrons sort of live in this energy field around the nucleus of that atom, and that's a pretty big deal because we couldn't really just like pick out an atom and see it and understand the electrons, which is kind of floating around. So I think that's a very important thing that we did for the physics community. Well, originally, I started my first year of college actually studying chemistry, and I enjoyed it, but I then switched to physics, and that was fun too, and I did some great experiments with that, but I've always liked biology, I don't know why.